When we put all of these pieces together, what we get is actually a function. We can tell since it passes the vertical line test. This kind of function is called a piecewise function because, well, it's defined in different pieces, since different functions are defined in different parts of the domain. There have to be at least two different equations defined in different parts of the domain for a function to be considered a piecewise function. What I'd like to know is what part of the domain each of these functions occupies. I'm going to switch over to piecewise function notation right now so that you can get an idea of what that looks like. So this is what typical piecewise function notation looks like. You can see that instead of separate equations for each part of the line over here, we've effectively merged them into one using this brace, this curly thing right here. This shows that all of these different function pieces are part of a single function f of x. Now the other important feature of piecewise function notation is this section over here to the right. This is where we show the domain that each part of the function occupies. Often you'll see a comma used between the equations for the different parts of the functions and their domain, but sometimes you'll see the word for written here instead, like this. To save space, I'm going to use commas right now, but either way is acceptable. Now, looking at the graph and thinking back to what you learned about Grant's tax brackets before, please fill in the different numbers that belong in these boxes to show what the domain of each piece of the function is. Now, I've been nice and I've already filled in the inequality signs for you, so all we need here are the numbers.